Now we're going to go on to the biggest topic for this lecture, which is scope. So think back to lecture about maybe lecture 3 or lecture 4, where we talked about variables and expressions. Do you remember us talking about frames? To jog your memory here, I have this slide, a screenshot of the slide. We talked about this idea of a frame, which is what the computer has in memory, and how when you execute a line like an assignment to a variable like num apples equals 5, what actually happens is the computer writes a series of zeros and ones in binary to somewhere in the frame in memory, and then labels that section of memory with the variable name. So we have num apples equals 5 is actually the number 5 written here, and this place in memory is labeled with the name num apples. And I talked about this as there being an analogy of kind of a notebook paper, piece of notebook paper, and that we call this a frame, and we're going to keep track of them and draw them as we talk about scope. And further on in this class, this kind of a blue box where we have a variable name, and then next to it is a little box, and we write the value of the variable in that box. So keep that in mind here as we start talking about scope. What is scope? Well, scope refers to the visibility of variables. And I'll answer this question, can I reference this variable here? And you probably haven't had to think about it before, because all of the code that we wrote always would get written to this global frame. And then if you referenced, so any assignment gets written to the global frame, and if you referenced any value, any variable, it would get read from the global frame as well. And so it'd be pretty easy to think about, hey, does this value exist, does this variable exist in the global frame? All you had to think about was, hey, was there a line above me that created that variable in the global frame? And so we would have code like this, like num apples equals 5, is bushel equals some other expression, num apples greater than 5. And when you run this code, the global frame gets filled in with these values, or with these variable names and their associated values. And then further on in the code, you could think through what happens, because you know that is bushel has already been defined. It's in the frame, and so when Python goes to look up this value from the frame, it finds false, and so we execute this else case here. Functions behave a little bit differently. So before we talked about just having a single page, this global frame. But when a function gets executed, for the time that that function is being executed, the function actually gets to create a new frame for itself, and we call this the local frame. So before we had a global frame, now this local frame is associated with a particular function call, this particular time that max value gets called. And now, any variable assignments that happen in the function get made in the local frame, only the local frame. And when you reference a variable, so if you try to use a variable name, Python will first look for that variable in the local frame, and only if it doesn't find it there will it go on to the global frame. Let me show you what I mean with this visualizer that I have. I'll share a link to this out on the class website. This is called Python Tutor, and it lets you put in some code, and it'll show you, visualize exactly what your frames look like. So when we run this first line of code, we see num1 gets added to the global frame. That makes sense. We have an assignment. Same thing, second line of code, num2 gets added to the global frame with a value of 12. Then we have line 4. Can you predict, by the way, what happens when the def statement gets executed? So when the definition of a function gets executed. Well, what this does is it actually creates a variable name, max value, and then the value that's stored in this variable name is actually this function over here. This arrow means a pointer, and we'll talk about pointers more a little bit later on in the class. But this just means this kind of a big thing that won't fit in this little box here. And so max value is a function that takes A and B. So now we've created num1 and num2 and max value. They're all in this global frame. Now what's going to happen when we call this print function? Well, the argument being passed to the print function is max value num1, num2, and this max value call is an expression that needs to be evaluated. So when we go to evaluate the expression, what Python will do is it'll go to execute the body of the function, and it creates a brand new frame over here, this max value local frame, and see how in this frame A has a value of 5 and B has a value of 12. That's because A and B are the parameters of our function, and as arguments we passed in num1 and num2. And so when we call a function, what happens is Python takes the arguments, so the actual values passed into that function, and assigns them to the parameters in this local frame that's created. So function goes to get executed. The parameters get assigned their values here, A5 and B12. And now we can continue on and step through the code. Now, if A greater than B, Python will go and look for this A and B, these references to variables, in the local frame. So it'll first check, okay, have I defined an A and a B? And yes, clearly I have inside of this function. And it'll use those values of A and B. Here, let's see. A is not greater than B, so we don't execute line 6, and we go to line 7 here. We're going to return B, and we get a return value of 12. And finally, we print out that return value right up here. 12 gets printed. Okay, doesn't seem so bad, right? Should intuitively kind of make sense. Okay, we're going to use the variables that are created in our function. It gets tricky. The place where it gets tricky is when there are names inside of a function that are the same as names outside of the function. So when there are different names in different frames. So let's look at this code together. We create num1 and num2 out here, 5 and 12. And so these are created in the global frame. And then we create this function max value. Again, when we create the function, not when we execute it, when we create it or define it, that is stored in the global frame because we have this name, max value, and then it has this function associated with it. But now when we go to execute print max values 4532, what happens? So what are the values for num1 and num2 inside of this function body? Does it use this num1 and this num2? Or does it use this num1 and this num2? And what values are assigned to these variables? Let's go back to Python Tutor and take a look at this example. So we have our code here. Yes, the same code that we were just looking at. Let's run this. So we know in the first two steps, num1, num2 are created, and our function is defined, a pointer to our function, just like before. But now, when our function gets called in line 9, a brand new frame is created. This is this local frame, max value, because it's associated with this particular function. And you can see inside of this frame, we have a num1 that has a value of 45 and a num2 that has a value of 32. And so when we get to line 5, which is inside of our function, it's being executed, any variable references first get looked up in the local frame. And if there's not, a matching variable there, then okay, then you go and you look at the global frame. But because we already have a num1 that matches, so we have the variable named num1 inside of our local frame, that is the variable that gets referenced. And the value that gets pulled is 45. So is 45 greater than 32? Yes, and so we return the value 45, and 45 gets printed to the screen. That's a bit of a tricky case. So just have the final result here for people who later look through the slides. By the way, no, I'll leave this detail out for now. Here's another tricky case. What about something like this? So def add up ABC. Total is equal to A plus B plus C. And at the end, we want to print total. So let's take a look together and see what happens here. So when this code gets executed, First, just like before, the function is created, add up. Then, when the function gets called, so 10, 5, and 6, a new frame is created. A, B, and C are assigned the values that are passed in as arguments, so 10, 5, and 6, as expected here. Okay, total equals A plus B plus C. All right, so now the total is 21. That's great. But here's a problem. Once our function is over, we go back to the global frame. And as soon as the function is over, that old frame gets discarded. And so when you go to run line 5 here, print total, because this is being executed in the kind of not inside of a function, it'll go and look at the global frame. And in the global frame, there's no total value. So we actually end up getting a name error here, that total is not defined. Because there is no total in the global frame, and that's the only place that you can look into it out here. You can only look at the local frame while you're within the function. As soon as you're done with the function, all those variables are discarded. We can't get to them anymore. So we get this name total is not defined error. How do we solve this? So what if you actually want to write to the global frame? You can do that. You can specify for a particular variable that when you write to that variable, when you assign to that variable, you want that assignment to happen in the global frame, and you do that with this global keyword here, global. So at the start of your function, if you put global space and then the name of a variable, that variable will then be used. It'll tell the function that any assignment that happens should happen into the global frame here. And again, this will just be easier for us to look into a visualizer together to see what happens. Here we have that same code, except adding global total. And now when this code gets run, just like before, in the global frame, we have just add up. The function call happens and A, B, and C are all assigned. But because this global total line gets executed, that will tell Python that if I do any assignment in this function to the variable total, I want that assignment to happen in the global frame and not in my local frame. And so when total equals A plus B plus C happens, you can see here that actually gets written to the global frame this time instead of the local frame. So total here is 21. And now when we come back out of our function, when we go to execute this print total line and we look at our frame to find the value for total, we look in our global frame and we actually have the value. So it's total 21. And so this line can actually execute. And we print out right here 21. One last detail here, I'll just reiterate, these local frames, I mentioned this before, but they get discarded as soon as the function is done running and the value is returned. So anything you assign in only the local frame disappears after the function is done. There's no way to access it from the global frame. Unless you decide to return that value and then make sure that wherever you call your function, you assign the output of that function or the return value to a variable in the global frame. Or you can do what I just showed you and write to a global variable. Let's take a look at some coding examples together to see this idea in action. So we'll come over here, and maybe we want to make some sort of counter variable. Counter equals 0. And then we're going to have a function that will just increment the counter by 1. This one. And maybe we'll want to print once, twice, 3 times, 4 times, finally print out the counter. Now, because this inside of this function body, counter doesn't exist. This counter that's being assigned is going to be a local counter. And so if you want to be incrementing this outer counter, you need to just specify that you want the counter variable to be global, which means write and read from the global frame, not the local frame, for this particular variable. So now when we run our code, python 3 main.py, we see our counter gets to 4. Again, increment 2 more times, and our counter goes up to 6. Just as an example.